Hey, Integrated One students. So today we are starting a unit on data and distributions. These are really important concepts. They're used in a lot of tech stuff, really any industry that uses data to try and predict how customers are going to act, or how nature is going to act, or how animals are going to act, or how financial markets are going to act, uses data and descriptions of data that we're going to start going over today. So the first thing that we need to talk about is the normal distribution. A normal distribution looks like this. So I'm going to draw an axis, two axes. A normal distribution kind of looks like this. And you've probably seen it before. A normal distribution reflects data that is kind of clumped around a central value, usually the average. So like the average of the data might be like right here, right in the middle of this range of data. It's a distribution, data distribution that's kind of shaped like a mound, and it's symmetrical. So if you drew a line straight down the middle of a normal distribution, the left side looks like a mirror image of the right side. So what the normal distribution is showing is data that is mostly clumped around a central value and that has some values that are to the left or right of that central value, declining as you get farther and farther away from that central value. So here's an example. Let's say that the average height of students at New Tech for freshmen, let's say the average height is 5'4". The middle of this data distribution might be 5'4". And maybe there's, I don't know, like 30 students that are exactly 5'4". And then as we get farther and farther out, there's less students that are taller. So for example, maybe this is 5'10". And maybe there's only 15 students that are 5'10". And then maybe way out here at the end, there's 6'4", and there's only one student who's 6 feet 4 inches tall. And same going backwards. Maybe there's 15 students that are 5'2" tall. And then maybe there's only one student that is, 5 feet tall, something like that. So this is kind of what a normal distribution means. There's like a center value, in this case, 5'4", that is the most common. And as you get larger and larger and smaller, farther away from that middle, that height or that value in the data becomes less likely. So a couple things, attributes of this graph we need to mention so you can do the work today. So this is a normal distribution. It is symmetric. It looks the same on the left as the right. These ends right here are called the tails. So the far ends, the far left and far right of this normal distribution is called the tails of this normal distribution. If a graph is skewed to the right, so we can have normal distributions that look a little bit different. Here's an example of one. So this is approximately normal, but it's skewed to the right. What that means is that the data is kind of stretched out to the right-hand side of the middle or the most frequent value in this distribution. So it's like a tail that's going out to the right. That's called a distribution that's skewed to the right or to the larger values. In this example of the height of students at New Tech, that would mean that the tail is skewed right or is skewed towards taller students. There's also being skewed to the left, which looks like this. This would be an example of a distribution that is skewed to the left or skewed towards smaller values. The last thing we need to talk about is the range. So the range of a distribution is taking the maximum value and subtracting the minimum value. So in this case, the range would be 6'4" minus 5 feet. There's 16 inches between 6'4" and 5 feet. So the range of this would be 14 inches. So we're going to get into other distributions, but this is the normal distribution. And the terms we went over were tail, skewed to the right or skewed to the larger values, skewed to the left or skewed to the smaller values, and the range of this distribution.